Section 3.4 is on page 198. It talks about a function or functions. What a function is, a function is a relation of distinct pairs, means separate points, or different points, not separate, different points, in which the first coordinate, the x value, does not repeat. Associated with a function is domain and range. Domain would be the allowable x values, and range would be the allowable y values. So, I'm adding examples since I can't see any in the book. There's only one problem, homework problem in the book. So, example, determine if the following relation represents a function. State the domain and range of each. I glance at number A, or part A. I say, okay, well, x is 1, 2, 4, and 5. 6. Since x does not repeat, this is a function. Domain. Allowable x values. What are the x values? 1, 2, 4, and 5. Range. Allowable y values. What are the y values? 2, 3, 4, and negative 1. 2, 3, 4. You could put them in order. You don't have to. That's okay. I look at part B. They're asking, is this a function? 1, 2, 4, 1. Make sure that they didn't repeat the point 1, 2 again, and they didn't. Those are different points. So you would say automatically, because of that right there, not a function. So what's a function? It's a relation in which the x coordinate does not repeat. Alright, what's the domain? A 1, 2, 4. What's the range? A 2, a 3, a 4. There it is. Now, if I was, it's not asking for this, but if I was to look at a graph for part A, if I was to plot these points, if I was to plot the point 1, 2, 2, 3, 4, 4, and 5, negative 1. I would notice that from a graph, it seems the domain is really x equal 1, x equal 2, x equal 3, x equal 5. And the range is really y equal a 2, y equal a 3, y equal a 4, and y equal a negative 1. If I look at the graph of part B, and again, that's not required, I'm just doing that as extra practice for what's to come. So if I am to move 1 to the right, 2 up, 2, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 1, 2, 3. So, if I am to look at the domain, again, it works out the same way. It's really those 3 values, and the range would be really those 3 values, right? Now, since I'm talking about x not repeating, x equal a number is a vertical line. If I fit a vertical line right there, a vertical line right there, and a vertical line right there, do you see graphically this shows that there are 2 different y's for this one x value? So, if I'm given points, I could figure out whether it's a function or not by simply following the definition. If I'm given a graph, then there's no point in me taking the graph and converting that to points. There's an easier way. I could just put a vertical line. If one x value consists of 2 y values, that's not a function. And that's what's known famously as the vertical line test. vertical line test states, a relation represents a function if no vertical line intersects its graph more than once, or a relation represents a function if every vertical line intersects its graph at most once. I like this definition more. On number 2 in the book, page 207, it says determine whether each graph represents a function. Well, it's fairly simple what to do. You would run a vertical line down, and you would see if it crosses more than once, that means for that one x there are two y's, and once you get an exception, not a function, you're done. Let's use something darker. Here we go. If I move to number example, I gave you some examples right there. Oh boy. Again, there's only one problem in the book. I want to make sure that we see a few of those. Example A, B, and C. By the way, something I should point out. Anytime the author draws a line like that, they mean this line is infinite. It continues on. They just don't put in arrows at the end, but all throughout this book, that's the assumption. So, if I get to number example A, I'll draw a vertical line. Basically, I'm looking for one exception. Is there anywhere in this graph I could draw a vertical line that will cross more than once? If I can't find it, then this is a function. And obviously here, x equal y squared, that x crosses twice, definitely not a function. And if I run here, even though it seems the majority seems to work, you're looking for one and only one exception. Because of this, this is automatically not a function. Now, if you do have a function, if you are given a function, we have what's known as function notation. What that is whoever's giving you the function is telling you that, whoever's giving you the relation telling you it's a function. You take your general y and you replace it by f of x. This right here reads f of x, not f times x, and this indicates that this y is a function. What does a function mean? It's a relation in which the x coordinate do not repeat, and if you graph it, it's going to satisfy the vertical line test. The first thing, we have to get used to this, and Euler came up with this. Euler, his name is extremely famous mathematician, and you pronounce it Euler, French. Most students say Euler, most non-students say Euler. That tells you who knows about functions and who doesn't. So Euler, he came up with this, and this is pretty much how he distinguished that. You see a y, replace it by f of x. If you have a function, you're telling whoever's looking at this that this is a function. And on number 11 through 28, and you notice g of x. So this is simply saying y equals 2x minus absolute value of 5 plus x, nothing more. When they say find the g of 10, they really saying if this is x, this is y, find y when x equals 10. Literally, wouldn't you say in this case y will equal 2, in place of x, wouldn't you put a 10 there? And you would apply order of operations. And the absolute value of 15 is 15. And 20 minus 15 is a 5. Now, let me do the same problem using g of 10. Well, g of x is right there. Do you notice whatever we put in for x, you throw it right there? Well, g of x, you're going to replace what we just did. When I say what's g of 10, go to g of x. Wherever you see an x, replace it by 10. So that's a 2 into 10 plus, minus absolute value of 5 plus a 10. It'll be wise to use parentheses every time you substitute, and students have a hard time with this. Look at this piece and look at this piece and tell me what is the difference. If I was to write this, students have no problem finding why. But if I say, what is this? This is saying g of 10, and if you clean it up, we already know that's a 5. This is saying when x equal 10, and there's x, g or y, g or f or L of x is the y. That's the point 10, 5. If I go by the second point, g of 7, if I find g of, negative 7, that would be, go to the right of this, that's 2 times a negative 7 minus absolute value of 5 plus a negative 7. Again, students have a hard time seeing this. But if I was to say, hey, can you replace x by a negative 7? Students have no problem saying y equal, and I'm talking about this part. Students have no problem saying y equal 2 times a negative 7 minus absolute value of 5 plus a negative 7. So look at that right there and look at this right here. They're the same. So you want to get used to this new notation. And this is saying y equals, that's what g is, negative 14 minus absolute value 5 minus 7 is a negative 2. Order of operations. The absolute value of negative 2 is a 2. And if you take negative 14 minus 2, that's negative 16. There's my answer. What this is saying, when x equal negative 7, y equal negative 16, nothing more. It's a point on the graph. I want to do another problem, number 14. And here, this is again y equals 6x squared minus 6x plus 4. And this is saying, if x equal 2, well, what is r of 2? Isn't that 6 times 2 squared minus 4 times 2 plus 4? Y would equal 6 times 4 minus 8 plus 4. R of 2 will equal 24 minus 4. And wouldn't that be a 20? There's my answer. Again, I'm just writing down what this means. I'm just telling you what this means. This is the final answer and you're done. This says when x equal 2, y equal 20, nothing more. And if I find r of negative 6, again, this is x equal negative 6, replace the y by it, and there it is. R of negative 6 will be 6. Negative 6 squared is 36. Plus 36 plus 4. And this is 36, 116. Plus 36 plus, that's 40. Oh, that's not true. This is 6 times 6 is 36, 18, 216, and r of negative 6 would be 256. Again, what this means, if x equal a negative 6, y equals 256. Now, we're going to change this slightly, and again, this is nothing more than you saying y equal x squared minus 2x. If x is a 3 plus c, do you agree that you're going to replace it in two places? If I say what's h of 3 plus c, wherever you see an x, replace it by those two values. That would be 3 plus c squared minus 2 times 3 plus c. That would be 9 plus 6c plus c squared minus 6 minus 2c. That would be c squared plus 4c plus 3. I have one more of those. That's all I could put my hands on. Y equal negative x squared plus 4x minus 9. Find it when x equal s minus 3. D of s minus 2. Wherever you see an x, right there. So you're going to say a negative, and you're going to square, plus 4, and you're going to multiply, minus 9. And what's x? It's that mess right there. It's really s minus 2. I know this doesn't look pleasant, but that's something we can't bypass. It's coming back our way, and we need to get that out of the way quickly. So what would that be? D of s minus 2 will equal negative, if you FOIL this, s squared minus 4s plus 4 plus 4s minus 8 minus 9 d of s minus 2 is going to equal negative s squared plus 4s minus 4 plus 4s minus 17, and d of s minus 2 is going to equal negative s squared plus 8s minus 21. The next set of problems is piecewise functions. Here you just have to kind of eyeball what this says. This y has 3 different values. Depending on what? Depending on what x is. X is less than or equal to negative 5. If the x falls in that region, y equal 1. Oh, I should have did that differently. That's okay. If x is between negative 5 and 0 not included, you would use that y. And if x is bigger than 0 or equal, you would use that function. They want us to find p of 0. So the question is always, where is 0? Look at those 3. 0 is right there. That means that's what y equals. That means you're going to throw 0 in there, and you're going to square it, and you get a 0. So on this graph, when x equals 0, y equals 0, if I take p of negative 12, that would be, where is negative 12? Negative 12 is to the left of negative 5. Since this is a function, this value will only be in one of those 3. So what does y equal? Y equal 1 regardless. This is a special case. And if I look at number 26, here we are. Good. This is, again, if x is, you don't have to put them on a number line, but it kind of helps to see what you're doing. So here, you could use this if x is less than or equal to 1. You could use this if x is between 1 not included to 4 included. And if x is bigger than 4, and they want to find k of 1. K of 1 is saying find the y value when x equal 1. Where do you think 1 is? Isn't 1 included right there or right there? That's the y you're going to use. You're going to use, in this case, y equal 4 minus 3x. So if you put a 1 in there, isn't that 4 minus 3 times 1? And k of 1 will be 4 minus 3, which is a 1. And if you want to find k of 4, again, you need to know which of those three functions to use. Where is 4? You notice 4 is included right there. Since it's included right there, that's really the y you're going to use. So this has a lot of benefits because you could call different y's. If x equal 4, isn't that 3 minus 4 squared? So associated with x equal 4, there it is. So this allows you to call different functions, kind of like doing your taxes. Depending on where your income is, you go to the certain bracket and go from there. Here again, I have 3 lines to worry about. This is if x is less than negative 4. This is if x is between negative 4 included to 3 not included. And this if x is greater than or equal to 3. Again, they could only include a value. You know, maybe you're thinking, what if x appears in 2 of those intervals? Not possible because those are functions. So if I look at n of negative 4, well, I need to know where negative 4 is. Negative 4 is included right there, so this is the x. We're saying find what y equal this specific y. Throw a 4 in there. And we get a negative 36. And if we try to do n of 3 again, I need to know where is 3. And that's really what we use in most applications for a lot of things. Where's 3? Well, doesn't this include 3 or it's right there? So there's the y. Y equal negative 4x minus 2. So negative 4, put a 3 there, minus 2. And that's the y that we want. 2 sections from now, actually we're going to do that next. We're going to graph those. And you'll see how that works. And that would be a negative 14. Next, set up a bit of a practice. It says, find the real zero such that the function equals 0. Where does this equal 0? And I'm pointing this out because last time you were asking about factoring. A minus indicate that you need to subtract to get 13. 3 and 1. Closest factors of 10 are 2 and 5, 5 and 2. Remember, you have to subtract to get 13. 15 minus 2, that works. And if you want a positive 13, don't you want a positive 15 and negative 2? That means the 3x minus 2 and the x plus 5. Well, 3x minus 2 will equal to 0, or x plus 5 equal to 0. X would be 2/3 or a negative 5. And here's another problem to practice as well. If they say, where does this equal 0? Well, you want to factor. They all have a 2 and an x. That would be x squared. I'm going to shift that to the left. Not so much. Plus 3x minus, then them all have, they all have an x. If I factor an x out, that's 2x squared plus 3x minus 20 equal to 0. So closest factors of 2 are 1 and 2. Factors of 20, closest 4 and 5, 5 and 4. Let's see if that works. I need them to subtract to get me a 3. 8 minus 5 is 3, that works. So 85% to 90% of the time you get it the first attempt. So this is x and 2 parentheses. If I want a positive 3, don't you want a positive 8? and a negative 5. So x plus 4 and 2x minus 5 equal to 0. That means either x equals 0 or x plus 4 equals 0 or 2x minus 5 equal to 0. So x equal to 0 or x equal to negative 4 or x equal to 5 halves. And if I look at find the real